Welcome back, Algebra Express. We are in Marecek 9.1 now. And so this is 9.1 and 9.2 combined. This is 9.1, the square root property is what we'll be learning. 9.2, I believe, is about completing the square. We are not going to officially go into completing the square, but I will show you like an example and talk about what they're talking about with completing the square. And so the first thing they give us is the square root property. So the solution x squared equals p, and then they tell us what it is. But I wanted to think about something. So x squared equals p. So throwing some numbers in there might help. So if we get something like x squared equals 9, I think most everyone is going to say something like x equals 3. Most people will get that. And if you get that, you get half of that correct. There is something else there that is possible. So when we square 3, we're going to get 9. But if we square a negative 3, so a negative 3 times a negative 3 is also a positive 9. And so this is basically the square root property. If we have something squared, we can take the square root, but we also have to account for the negative is the thing that you have to remember. So anytime you take a square root, plus or negative. So this is a square root property. The other thing you might see with this thing, so we see x squared equals 9, you're saying, hey, this is a quadratic. So can't I move the 9 to the other side, set one side equal to 0? You absolutely can. And you can factor it and solve it just like we previously have been. And you might notice this is a difference of squares. So hopefully this is also kind of telling you that you should get two different solutions. One where the x is a minus 3 when we subtract the 3 over, and one where x is a positive 3 when we add 3 over. So we still get the same solution. And sometimes, I'll go ahead and jump into it. If you see a plus and a negative, you might sometimes see these things written as like plus or minus 3. So when we say plus or minus 3, that literally means we have plus or minus 3. This is a way to represent two numbers. Okay, so that was the square root property. So anytime we take a square root of a variable, we add account for both the positive and the negative square root is what this is basically saying. So if we have something like 3x squared equals 75, So the thing I want to look at here is we have a 3x squared. So the x squared is obviously a square. But the 3, is that a square? This is not a square. It's being attached to this thing that is squared. So this looks like 3 times x squared equals 75. And so if this is multiplying, we might want to try dividing to get this x squared by itself. So if there's any coefficient or anything attached to our squared term, we're going to have to get rid of it. So x squared is 25. So if x squared is 25, I have to take a square root to get to x. But anytime I take a square root of a variable, this is the rule I'm talking about, I have to put plus or minus. So x would be a plus or minus, and we do the square root of 25 is going to give me 5. Okay. The next one, they're giving us it in function notation, so f of x equals x plus 4 squared. And they want to solve this equation for when f of x is equal to 16. So if we want to solve this, we know that x plus 4 squared is f of x, and we know that f of x is equal to 16. So putting these two pieces of information together, we can get this equation. And this is all about the square root property. So the kind of strategy that we want is we want to get our square term by himself. We want just a coefficient of 1. We just want something being squared. So if there's anything else there, we might have to divide it. Here, I want to look at what's being squared. So it's like this entire thing here is being squared. So this is the square. There is nothing out here in front of it. It's just this term being squared. So if I want, I can take a square root of this side. And I gotta also take a square root of this side. Anytime I take a square root of something that has a variable, I have to do plus or minus. Anytime you take a square root, the square root property tells you to do plus or minus. So I think I'm gonna write this out as 2 terms now. So I have an x plus 4, and I square root my x plus 4 squared. It is going to become x plus 4. So one of them is going to say x plus 4 equals, and I'm doing the square root of 16. 4, and one of them is going to say x plus 4 is equal to, now I'm doing the negative square root of 16, a minus 4. You can work this with the plus or minus notation, but I wanted to separate it because it would probably be a little bit easier to see. If we do x plus 4, subtract it, we get x is equal to 0 here. We get x is equal to a negative 8 here. And these are solutions, so if you want, you can go back and check. If we do 0 plus 4 and square it, we're going to get 16. If we do a negative 8 plus 4, that's going to give me a minus 4, and then I square it is going to give me 16. So these are things that we should be able to go back and plug in and check. So we will be able to check our solutions, but we won't be able to check maybe if we got all the solutions, right? So you do have to do plus or minus, or you might end up missing that thing. Okay. So this one, I think I'm going to keep the plus or minus notation when I do it. So I want to do x minus 1 squared equals 15. So the thing to notice is that our term that's being squared is by itself. If it's not by itself, we might have to do some work. So I have x minus 1 squared is equal to 15. And if I want to take a square root of that side, I also have to do it this side. But if I take a square root of a variable, the square root property tells me I have to take a plus or minus. So I'm taking a plus or minus root 15. So this side looks like x minus 1. We got rid of our square. This is equal to plus or minus root 15. And I'm going to do this maybe a little weird, but I have to add 1 to both sides. I could say plus or minus root 15 plus 1, but I'm going to throw this thing out in front. So I'm going to go 1 plus or minus root 15. Okay. And I want you to look at this. So this is our exact solution. So if they want an exact solution, and we are going to want exact solutions. We don't want you guessing these things and throwing them into your calculator, not knowing the process, right? We want you to understand this process here. So if I want an exact solution, this is the thing that they're talking about. The only other thing I didn't talk about, but 15, we have to make sure that this thing is fully simplified. And it's only a 3 and a 5, so there's no way I'm going to simplify this radical anymore. Root 15 is just root 15. So you might want to check those things. Okay, so we're looking at this, and I put like one thing down for my exact solution, but there are really how many solutions here? So that should represent 2 different numbers. One of them should be 1 plus root 15, which is, let's say, round it, to 3 places is where we want to go. 4.873. It is the first one. And the second one is like a negative 2.873. So this is basically a calculator check problem. Can you throw this into the calculator? Do you know what that's saying? Okay. The next thing looks like n plus 5 squared equals 32. So these are all student activities. So I'm hoping you give these things a shot by yourself before I start doing them. And they might introduce new things. Sometimes they introduce new things in the student activities. But that's part of math. You should be able to explore these things. And I know it took people hundreds of years to discover these things, thousands of years sometimes. But they also didn't have guidance quite as much. So if we guide you to the right area, hopefully that helps a little bit. So n plus 5 squared equals 32. If I'm looking at this thing, I want to look at my square root. Do I have my square? I want to look at my square term. Do I have my square term by itself? It looks like it here. So n plus 5 squared equals 32. So the thing I want to do is I want to take a square root. I got my square term by itself. I can take a square root. So anytime, make a habit of this. Anytime you take a square root, you can always get a plus or minus. So now I have something that looks like n plus 5. This looks like plus or minus root 32. Okay. Now I'm looking at this. I do have a little bit of simplifying to do on this root 32 over here. So root 32 is going to be what? 40. No, I could take out 16 is what I can take out. So if I look at this root 32, it's kind of like root 16 and 2, if that helps. Break it apart step by step. The other thing that I'm going to do is I have this thing. So I have n plus 5. I want to subtract 5 from each side. So it might be a little weird, but when I add or subtract that final term, I'm usually going to put it out in front. So minus 5 plus or minus this square root that we need to clean up a little bit. I get minus 5 plus or minus a root 16 is like a 4, and I still have another 2 underneath there. So the exact solution looks like minus 5 plus or minus 4 root 2. Again, this should be giving me 2 solutions. Plus 4 radical 2 and minus 5 minus 4 the radical 2. And so the first solution should be a fraction. I believe we're still going to 3 decimal places. If not, that's what we're doing now. 657 and a minus 10.657. Okay. X squared equals a minus 4. Okay, so this one I can see where people might mess up. X squared is equal to minus 4. We want to take a square root. We want to take a square root. So I want you to notice, like right off the bat, I haven't written my other signs, but we're going to take a square root of a negative number. The other thing is anytime you might take a square root of a variable, don't forget your square root property, that's the name of this game in this chapter, is plus or minus. Anytime I take a square root, got to put a plus or minus. Okay, this is an X. This is a plus or minus. Radical of 4 gives me 2. Radical of the negative means I should have an I in here. And just to recap, I'm going to write them out separately. This means I have a negative 2i and I have a positive 2i is what this thing is telling me. So this is a quadratic. Yeah, maybe you're thinking about this. Maybe. Yeah, something like this. Could we do this before? So before we would set one side equal to 0, you might notice this looks like a sum of squares. So previously we could not do sums of squares. We could not factor them and find the zeros. And we hadn't really talked about what the zeros and factors look like or their relation. That will come up a little bit later, but maybe try doing that equation and seeing what you get. It might be a fun little exercise. Okay. Don't want to jump into that quite yet. We will do another section when we talk about these relations a little bit more thorough and the zeros of a function and what that means. So x minus 6 squared equals a minus 25. Okay. So we have our square term. It is by itself, and it is equal to a negative number. So we're going to end up taking square roots of a negative on this one as well. So if we have something like x minus 6 squared equals minus 25, I want to take a square root of this, and I want to take a square root of this. But if I take a square root of this, I must put plus or minus in front of there. So this looks like x minus 6. This looks like plus or minus radical minus 25. So this thing over in here, I can clean up. This is 5i. So plus or minus, I take out the negative, it's an I. I take out the 25, it's enough, or 5. Minus 6, x minus 6 equals this thing. I'm going to have to add my 6 over. So x equals 6 positive plus or minus 5i. Okay, that is a complex number, but we can do it. And this is what I get for my solution. Just to reinforce that there are two different things here, I think I'm going to write it out twice. You can write it out either way is fine. I just want to be sure we get both in our notes. So 6 plus 5i is one of them. 6 minus 5i is one of them. I want to make sure we're splitting these things apart correctly. Okay. We used to cover 2 chapters. Now we only really cover this one. I believe this is the last one that is happening before we start getting into completing the square. So in completing the square, how can I say something? Let's start with, x squared. Let's suppose we have something that looks like x squared plus like 9x or something. And we want to know, what do we have to add for it to be a perfect square? And so completing the square is we're basically thinking about a square. So we can think about this as being x units. And this, in my example, this would be an x plus 3 squared. So I'm going to kind of give it to you, give it away. But this would also be like an x plus 3. So they are the same dimensions. That's why we call it a square. A square is like a polygon with the same length and side, all the same sides. So we have x plus 3 length and width. And so this is going to be like an x squared. Ooh, I did this wrong. Let's suppose we start with an x plus 6x, because we know that much. Sorry, that should be the 6x. I was thinking about the other number. And so we get something like this, plus 3x plus 3x. What we're asking ourselves, and this is x squared plus 6x in here. What we're asking ourselves is like, what would this thing have to be for this thing to be a perfect square? So if we just have a square term and a x term, we want to know what the constant number would have to be there in order for this thing to produce a perfect square, the perfect square being x plus 3 or x plus 3 squared. So we want to know, if we start off with something like x squared plus 6x, what is my constant term I'll have to add in order to make this thing a complete square? So when we look at something like x plus 3, I think it's easier to go the other way. So x plus 3 plus x plus 3, and that's kind of how I try to do it in my brain, and try to do it too quick and didn't do it right. But we know how to do it the other way. Let's start the other way. It's going to give me something like this. So if I know I start with x plus 3 squared, I do x squared plus 6x plus 9. And I want to know how this thing relates to this thing. So in order to get from 6 to 9, there's that middle guy of 3. So I am dividing by 2 to get to the 3. And then I'm taking this 3 and I'm squaring it to get to 9. So the very simple sort of way that we can do this is my b term. They will say we have to add b over 2 squared. So this is kind of like my magic number. And I mentioned it at the beginning of the notes, but this is completing the square. We are not technically going into this, but we are going to use it for something else. And so I want to throw it out there and make sure we know what's kind of happening. So basically what's happening is we're trying to find a number that we add to stuff that's going to complete the square or make it a perfect square. Like when we do the box method, right? We can think about these things kind of geographically, right? These are a geographical sort of approach that we're doing. We're actually saying that this thing is x units and this thing is 3 units. This thing is x units and this thing is 3 units. If we wanted to find the area here, x by x gives me x squared. So this is like finding the area of the box, is literally what the box method is doing. So where it spans from is finding areas. And then they put crazy symbols in there and try to make things more complicated because they're mathematicians. Okay, so this is, I don't want to go too fast, or too slow, or spend too much time on this, I guess is what I'm saying. I don't want to spend too much time on this, but that's x plus 7 squared. We've done this before. You can do this, they say trial and error. You can do this with AC method. You can do this multitude of ways. They're trying to get you to notice something about the relation between this thing and this thing, I believe. But we want to do completing the square just for like 1 or 2 examples. I'm not going to go too deep into it. But we have something like x squared plus 4x equals 5. If we want to do this with completing the square, I talked about that magic number of b over 2 being squared. So if b over 2 is squared, what we're doing is 4 over 2 and squaring it. We're going to do 2 squared, so we need to add 4 is the magic number I need to add. So x squared plus 4x, I've got to add 4, and if I add 4 to that side, I also have to add it to the other. So this thing is x squared plus 4x plus 4 is equal to 5. This thing is now a perfect square. This thing gives me the sign on the perfect square, so it is an x plus. And if you really want to look back, it would be this number right here. X plus 2 squared is equal to 5. So you should be able to factor this even if you don't know these little shortcuts you might be able to grab stuff from. But we could factor x squared plus 4x plus 4. We know how to factor those things through the AC method. There's something that we can do. But this looks like x plus 2 being squared is equal to 5. So this side, we made it a perfect square. Ooh, no, it's not 5. Y'all should call me on that. 5 plus 4 equals 9. Sorry. Got to add the 4. I said it, and I didn't do it. And that is a really common mistake. So I'm trying to go through these fast, and I'm probably more prone to make mistakes. But it's a really common mistake to add it to this side and not that side, and I just did it. So there's your demonstration. Don't do that. So now we want to take the square root of both sides. So this is x plus 2. This is the square root of 9. But anytime I take the square root of a variable, I have to do plus or minus. So what this looks like is that I have an x equals a minus 2 plus or minus a 3. So this looks like minus 2 plus 3 is going to give me 3 minus 2 is 1. And then the other thing would be minus 2 minus 3 gives me a minus 5. So my two solutions are 1 and minus 5. Okay. So that, to be honest, doesn't even look like something you have to do by completing the square. We're getting just regular whole numbers out of that thing. We probably could have done this if we set one side equal to 0. But there are some things that we need completing the square to get to that we probably cannot do with AC. So we're expanding what our solutions can kind of look like. Okay, so maybe one more. Let's jump to, I don't know, number 4. This looks like a good heavy one. Hopefully it'll give me something. Okay, so if I have this thing x squared minus 4x plus 90, I want to do this with completing the square. So in completing the square, so previously we always set one side equals 0. In completing the square, we just want the x squared and the x on this side. So I'm going to have to subtract 90 from both sides. It's going to be my first step. And this is going to be equal to a minus 98. And people do these differently. They don't always just move them on one side. But this is my sort of preferred way. I want to do b over 2 squared. Figure out what the heck b over 2 squared is going to be. Minus 14 over 2. And then we square it. This is going to be a minus 7 squared, which is 49. So I want to add 49 to both sides of this thing. So x squared minus 14x plus 49 is going to be equal to negative 98 plus 49. Is that going to be minus 45? Oh, no. Negative 98 plus 49. Did the wrong numbers. I thought that sounded wrong. Minus 45. So now that we've added the magic number, this should be a perfect square. This is like x. That sign's going to give me the sign. And this should look like probably like x minus 7. So again, if you want to look back up, you might notice that minus 7 somewhere up here. That might give you a hint into what this factors into. And you may not have to do AC method then. Well, you don't have to do it anyway. You aren't going to do these straight up. We're using these as a kind of stepping stone to get to something else. But this is, I have to do plus or minus. Did I do my note? Haven't done it yet. Sorry, this is still minus 49. The next step, I'm going to take a square root of both sides. So I do x minus 7 squared, and I take the square root of this. I take a negative 49, and I take the square root of this. I always have to do plus or minus. So this looks like x minus 7 when it comes out of that square. This looks like a plus or minus. And root minus 49, that's an even root. That's a 7. But it's also got a I attached to that thing. So now if we add this 7 over to solve for x, we get something like 7 plus or minus 7i. And so now we get things that look like complex numbers. So again, the sort of strategy to completing the square is to make it a perfect square. And then once it's a perfect square, it's the thing that we were doing previously. We can take the square root property. And anytime I take the square root property, always got to do plus or minus. So with the square root property, with completing the square, we can actually get to numbers that look like complex numbers. It's getting us more complicated solutions is what it's happening. Okay, so that's the final one that we're going to go over today. There are a few other examples there. You're not really expected to know how to do the completing the square. Like I said, we're using it as a stepping stone. Know how to do the square root property. Know the square root property. Know that anytime you take the square root of an equation with the variable, you always have to put that plus or minus. That's the thing to really take away from today. So I know it's a bit of a short lesson, but they cut part of it. So I will see you in class and take care.